Assalamualaikum and greetings everyone. We are still on common surfaces. The next common surface that I'm going to show you is hyperboloid of two sheets. This is the general equation for the surface. Here A, B and C are all constants. Let's go straight to an example. Okay, so here we have an equation z squared equals 1 plus x squared plus y squared over 9. We know that x, we can square any real number, so no restriction on x here. We can square any real number, so y, no restriction on y there. And on the on the left hand side we have z squared. So at first glance you might say z can be any real number as well. But when you look at the expression on the right hand side, we have this x squared plus y squared over 9. So this expression here is always larger than or equal to 0, because when you square any value it will give you a positive value, or the least is 0. So x squared plus y squared over 9 must be larger than or equal to 0. And here we have z squared is equal to 1 plus an expression that is larger than or equal to 0. So from there we know that z squared in this case must be larger than 1, because we have z squared is 1 plus this expression here, which is larger than or equal to 0. So z squared must be larger than 1. Okay, so now let's look at z again. Oops, sorry. Okay, so z squared is larger than 1, so from there we should know that z must be larger than or equal to 1, because when you take a value larger than 1 and you square that, obviously it will be larger than 1. But z can also be less than or equal to negative 1, because when you take negative 2, when you square negative 2 you get a 4. Definitely 4 is larger than 1. So for z, it has to be, to pick a value of z, you should pick a value that is larger than or equal to 1, and another one is less than or equal to negative 1. So those are the values of z that we should choose to get the level curve. Remember the view from above, we need z as a constant. Okay, so let's sketch a few level curve for different values of z. So definitely z equals 0 cannot be, we cannot use z equals 0, because z equals 0 is not in a that will give you invalid equation. Okay, so z must be larger than or equal to 1 or less than or equal to 1. Okay, let's pick that one. Z equals 1. When z equals 1, the equation becomes 1 equals 1 plus x squared plus y squared over 9, or rewriting the equation we get this equation equals 0. So there's only one solution for that. It's just a point at the origin. Okay, so when z is 1, we get a point on the xy plane. So here we have a point. Okay, it's not a curve, it's just a point. And then when z equals, I'm going to choose negative 1. When z is negative 1, we end up with the same equation. We have x squared plus y squared over 9 equals 0 as well, because when you square negative 1 here, you get 1. Okay, and then replacing right down the right hand side, simplify it, we get the same equation. For z equals 1 and z equals negative 1, we have the same shape of level curve, which is just a point. The origin, my goodness, sorry about that, which is a point x0, y0. Okay, so with 2 points, z equals 1 and also on the z equals negative 1, you cannot tell much about the surface. Okay, so we need more level curve. Okay, let's pick z equals 2. Okay, we can pick z equals 2 because 2 is larger than 1. Okay, so when z is 2, we have, we're going to plug in this equation. Okay, in this equation. So we get on the left hand side, 2 squared is 4, and here we have 1 plus x squared plus y squared over 9. Rewriting that, we have this equation, which is really an equation of an ellipse, but not in a general form. So I'm gonna simplify or modify the equation. For 3 to be equals 1, we have to divide by 3. So 3 by 3 is 1. Divided y squared over 9 with 3, we get 27. And here we have x squared over 3. Okay, so we have that. And this is an equation of an ellipse. Equation of an ellipse. We can sketch that on the xy plane here. Okay, so here we have x-axis, y-axis. Alright, 27 is definitely larger than 3. So your ellipse is longer parallel to the y-axis. So that would be square root of 27. And this is negative square root of 27. And here we have square root of 3. And here we have negative square root of 3. And this is our ellipse. Okay. Alright, and then we need one more. How about z equals negative 2? When z equals negative 2, we end up with the same equation, because negative 2 squared will give you a 4 as well. So for z equals 2 and negative 2, the shape of your level curve is the same. It's the ellipse of the same size. Okay, so now we have 4 level curves. One is for z0, one is for z equals 1 and negative 1. We only have 2 points there. And the other is for z equals 2 and negative 2. We have an ellipse of the same size. Okay, now we need the view from the front and the side. Okay, so this is our equation. Alright, this is our equation. So we can pick x0 here because x can be any real number. So 0 would be a good choice. Alright, so when x is 0, so now we're trying to sketch the traces, the view from the front and the side. When x is 0, we get z squared is 1 plus y squared over 9. Okay, because we replace x with 0. And then rewrite the equation so that we can recognize the shape of the equation. So we end up with that, and we know that this is an equation of a hyperbola. Okay, all right, now let's sketch our hyperbola. It's going to be, well, we need y and z axis. Right, here we go. This is y axis and this is z axis. Alright, so from the revision, you can see that z squared, the coefficient for z squared is positive. So our hyperbola open along the z axis. So here we have, this is 1. And here we have a 1 as well. Negative 1, sorry. So it opens along the z axis. So it opens like so. Alright, so it's a hyperbola. So that would be the view from the front, and we need another view which is from the side. Let's pick y equals 0. So when y is 0, the equation is that's z squared equals 1 plus x squared. Rewriting the equation so that we can sketch the equation easily. Again, this is a hyperbola. Okay, when we sketch this, we need the x and the z axis now. Okay, so here we have x-axis, z-axis, and now you can see that again the coefficient with the positive coefficient is for z. So your hyperbola opens along the z-axis. So let's say that's a 1, and this is negative 1. So we have this hyperbola like so. Oops. Let me move this further up. Alright, so we have a hyperbola. Alright, now the fun part, putting everything together. Okay, so let's put everything together. we need the XYZ space. And so the Z-axis, X-axis, and the Y-axis. And we also need the negative part. So here we have the X, negative Y, negative Z. Okay, sorry, negative X. All right, so remember we plotted 4 level curves. One is for x1 and -1. Okay, we have a dot, 2 dots, and also for z2 and -2. Okay, so we have z equals 1. Okay, let's say that's a 1. Gonna sketch that here. And we also have 2 and -2. So we have, that's a 2. And here we have a 1, -1, sorry. And this would be -2. Okay, so we're going to sketch the level curve on these 4 planes. Okay, the first one is for z1 and -1. For z1 and -1, we only have points, 2 points, all right? And then for z equals 2 and -2, we have the same size ellipse, which is this, okay? It's longer parallel to the y-axis at square root of 7 and negative square root of 7, and then square root of 3 and negative square root of 3. Okay, let's say this is square root of 7, and 1, 2, 3 here, and we have, oops, that's wrong, my goodness. We're supposed to sketch this on z equals 2. I'm sorry about that. This is z equals 2 and -2. Okay, we have one here, 1 point there for our ellipse. Okay, we have this ellipse, and we have the same size of ellipse on z equals -2, which is here. So the same size, it will go there and here, is that right? And here, and here. Okay, so we have the same size of ellipse for z equals 2 and -2. Okay, all right. Okay, and then we have the 2 views. One is for x equals 0. This is the view from the front. Okay, we have a hyperbola. So we have this hyperbola. You can draw a bit larger if you like. Okay, and the view from the side, it also intersects z-axis at 1 and -1. So we have another hyperbola, like so. And here we have another hyperbola, like so. And of course, you can sketch this much larger. Okay, so you can see that we have 2 pieces. One is at the top here, and one is below the xy plane, and we have nothing in between z, -1 and 1. Nothing, no curve there, no surface there. Hence the name hyperboloid of 2 sheets. Okay, so it has 2 parts. All right, so I think this is an interesting surface. Okay, for the next surface, I'm going to save that to the next video. Thank you.